Hello students, in the previous video we have seen some of the properties of GP, and in this video we are going to discuss some more properties of GP. So the first one we are going to discuss is when we take a finite GP, the product of the terms equidistant from the beginning and the end is always the same, and that will be equal to the product of the first and last term. So if suppose take a sequence A1, A2, A3, so on up to AN is in GP, then the product of the terms equidistant from the beginning and the end. The first term from the end and the beginning will be A1 and AN. So A1 into AN will be equal to the second term from the beginning and the end, that is A2 and AN minus 1. So A2 into AN minus 1 will be equal to A3 into AN minus 2, so on up to AR into AN minus R plus 1. For example, take a GP with first term A and common ratio R. So the terms in GP will be A comma A into R comma A into R square, A into R cube, so on up to A into R power n. Now let's take the pth term from the beginning and the end. Pth term from the beginning will be AP, that will be equal to A into R power P minus 1 using the formula of nth term of a GP. Now similarly, pth term from the end will be N minus P plus 1, that will be equal to A into R power N minus P plus 1 minus 1. So this will become A into R power N minus P, because we can cancel 1 and 1. Now when we take the product of these two, it will be AP into AN minus P plus 1, that will be equal to A into R power P minus 1 into A into R power N minus P. So this will become A into A is A square into R power. Using the property of exponents, we can tell that x power A into x power B is equal to x power A plus B. So this will become A square into R power P minus 1 plus N minus P. Now plus P and minus P can cancel out, and we'll be left with A square into R power N minus 1. Now this can be written as A into A R power N minus 1, which will be equal to A into, now what is A into R power N minus 1? This is the nth term, right? And A is the first term, which is A1. So from this we can tell that the product of the terms that are equidistant from the beginning and the end will be equal to the product of the first term and the nth term always. Now let's discuss one more property, which will be that every term of a GP is the square root of the terms equidistant from it. So suppose TR is the term, then the terms equidistant from it can be represented by TR minus P and TR plus P. And the relation between these three terms will be that TR will be equal to square root of TR minus P into TR plus P. Now let's see a simple example by taking a geometry progression with first term A and common ratio R. So the GP will be A comma A into R, AR square, AR cube, so on. Now nth term will be equal to A into R power N minus 1 using the formula of the nth term of a GP. And Tn minus P will be equal to A into R power N minus P minus 1. Similarly, Tn plus P will be equal to A into R power N plus P minus 1. Now when we take the product of these two terms, it will become Tn minus P into Tn plus P, that will be equal to A into R power N minus P minus 1 into A R power N plus P minus 1. So this will become A square into R power. Here we can again use the property of the exponent, that is x power A into x power B equal to x power A plus B. Then we'll have R power N minus P minus 1 plus N plus P minus 1. So this will become A square into R power minus P, and P can be cancelled out, and we'll be left with 2 times N minus 2. So this will be A square into R power, taking 2 common, 2 times N minus 1. Now this will be equal to A into R power N minus 1 whole square. And we know that A into R power N minus 1 is the representation of the nth term. So this will be Tn whole square. Now when we write this equation, we'll have Tn minus P into Tn plus P equal to Tn square. Now taking square root gives Tn equal to under root of Tn minus P into Tn plus P. So from this we can tell that every term in a GP can be written as the square root of the product of the terms that are equidistance from it. There are some more properties of GP which we'll be discussing in the next video. Hope you understood well. Thank you.